we're going to talk about logarithms. Logarithms, a lot of people tend to have a lot of trouble dealing with logarithms and the mathematics of logarithms. So let's just get a few basic concepts here together and hopefully it'll be much easier for you. So a logarithm is an index. We've come across index or powers before. So all you've got to think about when you think about logarithms is you're dealing with powers of numbers. Those powers have properties and rules, and so anything that applies, any of these rules that apply to logarithms, we've already seen the same sort of rules that apply to indexes, the laws of indexes when you're multiplying numbers, etc., etc. So a logarithm is an index, and we've got to remember that. A definition: if some number n can be expressed as some base to some power, then the log of this number to some base, log, don't forget, is the index. What's the index? You've got to raise a2 to get the power of n. It's got to be raised to the power of x. Well and truly worth remembering the definition that if n equals a to the x, then the log of n to base a is equal to x. That is a definition of a logarithm. So we've seen with exponential functions, simple exponential functions can be expressed as y equals some base to the power of x. So there is a simple exponential function. We can say that's f of x is equal to some base to the power of x. So from our definition up there, what we can say is that the log, in this case up here we had n, now we've got y, the log of y to base a is equal to x. Now, if we want to work out what the inverse of an exponential function is, that will be our first step. We've already seen that these graphs, we can apply the horizontal line test and it'll only cut the graph once. So a to the x, don't forget, is going like that. And the horizontal line test, so we already know that we've got an inverse. So our first step is to apply the laws of logarithms, and because we want to make, in this case, x the subject, which we have, and our third step is to interchange x and y. So from that we can say that instead of that x we can put a y instead of that, so the log of a to base x. So we're saying that this is the inverse. So if this is f to the x, then this is the inverse function, which we write f to the minus 1. So taking the log is exactly the opposite of raising it, of the exponential function y equals a to the x. Now the final steps were to do the verification. So we've got f of f to the minus 1 of x, and f, the function is a to some power. Now instead of that we will write what the inverse is, and that is log x to both a. Now this is the power you must raise a to get the number x. If you raise a to that power, you're just going to get the number x. F to the minus 1. So the inverse of f of x. So the inverse function looks like that. So we've got log to base a of x. Now instead of that x, I'm going to write the original function, which is a to the x. Alright, so you've got the log of a to the x to base a. What is the power you must raise a to get a to the power of x? Well, that must be equal to x. So we've shown now that the inverse of y equals a to the x is y equals log x to base a. So these are both inverses of each other. So there's an introduction to logarithms. Always think, when you think logarithms, think indexes. A definition: if n equals a to the x, then the log of n to base a is equal to x, and then I've just shown here that the log is the inverse of the exponential function.